Okay, in this video we're going to continue on with naming chemical compounds, but we're going to focus on naming compounds that have polyatomics or polyatomic ions. What polyatomic ions are is they're ions, so they have a charge, either positive or negative, and they're sort of this little group of elements that always sort of travel together. They're almost like a mini compound, you could almost think of them as. So in this first one, my CaCO3, my polyatomic is this CO3. So my CO3, my carbon, when it's bonded to 3 oxygens, it's going to have a charge and it's going to have a specific name, which we'll look at in just a second. It's a polyatomic. So it always travels together, and we're going to treat this CO3 as a unit. Okay, so on the back of your periodic table, you have a full list of polyatomics. Those charges for the polyatomics actually apply to that entire polyatomic atom, that entire unit, that CO3, or whatever your polyatomic is. Okay, so let's take a look at this. Let's practice with CaCO3 and our other examples that we have here. So, first thing, a red light that you have a polyatomic is if you have more than 2 elements, or you have more than 2 capital letters. That means you probably have a polyatomic in there. So check on the back of your periodic table to see if you can find your polyatomic on that list. You also have to balance the charges. So remember, I'm still dealing with ions, so I still have to balance charges so I have an overall neutrally charged molecule. Okay? So it's pretty easy when going from a symbol to a name. I essentially just name everything in that molecule. So CaCO3, my first element is calcium, and my CO3 from the back of my periodic table is just carbonate. And notice in my rules and tips, I no longer have ends in "ide." So when you have a polyatomic, you're just going to end with the polyatomic name if your polyatomic comes second. And for the most part, it's going to. There are very few exceptions. For the most part, your polyatomic is going to come second. So down here, my K2SO4, my K2, my K is potassium. And because I'm working with ions, no prefixes, so I can ignore my subscripts. That 4 is actually part of this whole polyatomic. So I look up my polyatomics. SO4 is actually sulfate. And most of your polyatomics are actually going to end with ate or ite. There is one, hydroxide, is going to end with ide, so be careful with that one. It doesn't sound like a normal polyatomic, but OH minus 1 is a polyatomic, and it's hydroxide. So just be aware of that one. Then there's a couple others. Acetate and ammonium are polyatomics that don't end in ate or ite, ITE, but for the most part, they will. Okay, so NH4, NO3. So now I actually have 4 elements. So if I flip over my periodic table, I'm actually going to notice that I have 2 polyatomics, NH4 and NO3. So all I have to do is name them each. So NH4NO3, my NH4 is ammonium, and my NO3 is nitrate. Okay, I also have nitrite and sulfite. It just so happens that all of the examples I chose all ended in 8s. Okay, so look over your periodic table list of polyatomics to sort of familiarize yourself with those. Okay, here are 2 other examples I want to point out, because notice here I have, for number 3, I follow the rules of transition metals if a transition metal is present. So you can't just forget about the rules of your transition metals or your ionic compounds. They're still there because you may have a polyatomic paired with a transition metal. So we just looked at polyatomics paired with regular ions, but what happens if I have a polyatomic combined with or paired with a transition metal. So in these two examples, I have just that. I have lead, which is a transition metal, bonded to a polyatomic, and I have zinc, which is a transition metal, bonded to a polyatomic. So when we're doing this and going from symbol to word, remember, don't forget you need to use your Roman numerals when writing out your names for your transition metals so that you can identify the charge or the ion, the specific ion that transition metal is going to become in that molecule. So for PbSO3, my Pb is lead, and my SO3 is actually sulfite. So then I look up my charge for sulfite, and my charge on sulfite is -2. And so since I only have one sulfite and one lead, this must mean that my charge on lead is a +2. So this is actually going to be lead 2 sulfite. Okay? And down here I have ZnCN2, so I look up my polyatomics. I don't know what CN is, but I look it up and it's actually cyanide. So my charge on cyanide is a -1 on my periodic table. So I've got zinc and cyanide. So my charge on cyanide is -1, so I have a total, but I have 2 cyanide, so I have a total -2 charge, and I only have 1 zinc, so that means that my zinc must have a +2 charge. So this is going to be zinc 2 cyanide. And a note, just like we saw in the other video with silver, zinc, even though it's a transition metal, it is almost always going to have a +2 charge. So you actually won't often see it zinc 2. This is correct, but most of the time this will be left off, since zinc 99.9% of the time is going to be this +2 ion. So most of the time you'll just see zinc cyanide, because it's zinc is so often a +2 ion, we can just assume that it's a +2. Okay? So when you have a transition metal and a polyatomic, you have to follow the rules for both. So find your charges, find the charges, work backwards so you can get the charge of your transition metal, write it as a Roman numeral, and then finish the compound with the name of your polyatomic. So now when we're going from name to symbol, we're going to follow a procedure very similar to our regular ionic compounds. So we're still going to have to do our swap and drop, balance our charges, and work from there. So the first one, aluminum hydroxide. So I have aluminum, and I look at the back of my periodic table, and hydroxide is an OH. So I find my charges. My aluminum has a +3 charge, and my hydroxide has a -1 charge. So to balance this out, so I have a neutrally charged molecule, I'm going to swap and drop. So my aluminum is going to stay 1, and this 3 is going to apply to my hydroxide. But my hydroxide is this entire OH group. So I have to put my OH group in parentheses and put the 3 down here so that I make sure that this 3 applies to my entire hydroxide group. Okay, so if you have more than one polyatomic, you have to put your polyatomic in parentheses and put your subscript to the outside. So I know it's referring to the entire polyatomic group. So calcium acetate. So I look at my periodic table, and calcium has a +2 charge, and acetate, which is kind of a long polyatomic, has a -1 charge. So right, my calcium and my acetate, which is actually C2H3O2. So I'm going to swap and drop. So my 2 is going to go to my acetate. So I have to put my acetate in parentheses with the 2 on the outside, so I know that I have 2 acetates, and my calcium is a -1. So I have 1 calcium with a positive 2 charge, so I've got a total positive 2, so my calcium with a +2 charge, and I've got 1 of them, so I have a positive 2 charge here, and each of my acetates have a -1 charge, but I have 2 of them, so I have a -2 charge there. So my +2, my -2, and it's neutrally charged. My sodium chromate, so my sodium is going to be Na, and my chromate is actually going to be CrO4, and my sodium has a +1 charge, and my chromate has a -2 charge. So now I swap and drop, and this has to become Na2CrO4, and that's my sodium chromate. Down here, I actually have this Roman numeral, so it tips me off that I have a transition metal in my cobalt. So my cobalt is going to have a +3 charge, and my carbonate has a -2 charge. So I'm going to have cobalt, and my carbonate is CO3. So notice this illustrates the importance of having your lowercase versus your uppercase letters so that you can tell whether it's an element or a polyatomic. Okay, so I have my cobalt, C(o), and my carbonate, C(O)3, and I swap and drop. My my 2 comes down to cobalt, my 3 comes down to carbonate, so it's CO2, 2 cobalts, and 3 carbonates. So CO2, CO3, 3. And each of my cobalts has a +3 charge, and I have 2 of them, so I'm going to have a +6 charge. Over here I have 3 carbonates, each with a -2 charge, so -2 times 3, and I get -6 to balance my +3 times 2 +6 charge. So now I have neutrally charged molecules. Okay, and that's how you name compounds with polyatomics. Okay, either going from words to symbols or symbols to words. Okay, use the list in the back of your periodic table to help you and these tips and tricks, and you can't go wrong.